Hey, Algebra 1, welcome back for lesson 3. We got to get started pretty quick. We have a lot to do today. No fun and games. Okay, today is our last day where we're going to be talking about the essential question from this week. And for the last couple lessons, we've been talking about the exponent part. Well, now we're going to talk about the radicals. Okay, so it's a little bit of new vocabulary and a whole new topic. There will still be exponents, but we're going to focus on radicals. And what does that mean? So 7.4, radical expressions. All right, so I put up a little bit already on the board. We have the idea of a radical, which is the same thing as a square root. There can be other roots, and they're all called radicals. So a radical expression just means it has some math problem has a radical in it. So let's figure out what is a radical. Well, let's start at plus and minus. Plus versus minus, they're opposites, right? Multiplication versus division, these are also opposites. So when we get down to x squared versus square root of x, these are opposites. So the exponent is the opposite of the radical. So if they're opposites, that means if we do both things, they will cancel each other. So if we do a radical and an exponent, they will cancel and we will just have the x left over. Okay? So the square root and the squared, other names for them, delete each other. Same thing happens here. We have a square root and a squared. So all that's left inside is that 2. Okay, they're opposites. This is like saying plus 1 minus 1. You're going to get back to 0. Okay, now let's check what we know. 2 squared is the same thing as 2 times 2. Right? We did that last week and last lesson. So if these are the same thing, they should have the same answer, right? That makes sense. If it's the same number with a different disguise, it's going to get the same answer. So that's something we know now. If we find 2 of the same number under a radical, we know one of them, we know the answer to that is 1 of that number outside the radical. So another thing we know, 2 times 2, that's 4, right? So this is the same number in a different costume. So it's also going to be 2. And we might know that, right? Square root of 4 is 2. Okay, so if we want to talk about these, get some good vocab for them, the name of this symbol, the little heartbeat, is the radicand, okay? So we could say a radicand and a square cancel each other. If you have 2 of the same number under a radicand, the answer is 1 of them without the radicand. Okay, so this is a good reference board. So now we know the vocab and what a radical might do. Let's move over to one of the properties of radicals and how we could deal with them. So just like I said before, we're only going to be dealing with square roots. So today, square roots is the same thing as a radical. Okay? So let's look at some properties of a radical. This is called the product property of square roots. Product, we know from before, the product means multiply. So this is the multiplication rule for how to fix radicals. We did product rule of exponents last time. Now we're going to do products with radicals. All right, so we have a radical here. We got A times B, right? If 2 letters are next to each other, they're multiplying. So square root of AB. And we know that's the same as the square root of A times B. Same thing. AB is just another way to write A times B. So if that's true, the rule is we can break them apart if they're multiplying. So if you have two things inside a radical under a radicand, you can break them apart if they're multiplying together. So here there's multiplying. We can split them into two different radicals that are multiplying. Now that's going to come in handy. So let's take what we just figured out. Let's try it out. What if I want to split this apart to get an answer to it? Now, we know from before parts of this answer, but to make it simpler and in other problems where it's going to be pretty hard actually, we're going to break it apart. So just like I said here, let's check it out. 4 next to a letter, that means they're multiplying. So I'm going to write that. 4 times x squared. Okay. Now we also know if two numbers are multiplying under a radical, we can break them apart multiplying. So square root of 4 times square root of x squared. Okay? Now this is a good example because we just have to think back to the last board. And what did we get for our answer? Nice catch. What did we get for our answer when we had square root of 4? Well, that was 2. And what did we get when we had square root of x squared? Remember, square root and squared, they cancel. So all we had left was the x. And there we go. Finished answer. So this was a little bit easier of an example, but you can see how it's nice if we break it apart, we get all the little pieces and put them back together at the end. So let's try only numbers this time. So look down at the next line. We've got square root of 20. So square root of 20, I don't know. The calculator knows, but let's see if my calculator's working. Square root of 20. No, this thing, it's not that great. Okay, so we don't want some weird decimal that my calculator gives. We want the real radical answer. Radical dude. Okay, so what we can do is break it apart like these. So what I'm going to say is, here's my big radical, my big radicand. What can I break 20 into? Like, what are the factors of 20? Well, I know it's 2 times 10, right? But what can I break the 10 into? 10 is 2 times 5. So 20 is 2 times 2 times 5. This is the prime factorization of 20. You've probably done this before. So prime factoring, or just any factoring, it can take a little bit of time, but there's no way I could find the real answer to this without a calculator, and the calculator's just going to give me the decimal, and I don't want the decimal. Okay, now we can break it apart. So from the last board, I remember when I had 2 times 2 under a square root, if I have 2 of the same number, we can get them outside the radical. So we can have 2, well, let me just do it fast, slower. We can split it apart. 2 times 2 is 1 of ours times 5, square root of 5. Okay? Then answers will go in black. So now I remember, if you have a radical with 2 of the same number or 2 of the same letter, we can delete the radical and get one of the letters or numbers outside. So here we go. Okay. And square root of 5, unfortunately, it doesn't have a nice square root, right? We know square root of 4 is 2. Square root of 9 is 3. So it's going to be some bad decimal in there, and that's what your calculator would give you. But if we just want this, we don't need any calculator to get the decimal. We just want to leave it as square root of 5. We know that we can't make this any smaller without making a decimal, and we don't want decimals. Okay? All right, last example on this section. What if we have numbers or letters on a fraction here? Well, it's the same idea as the first rule, product and division rule. So we can split it apart into square root of the top divided by square root of the bottom. So we can split it top to bottom. Okay? 16 was our top. 9 was the bottom. Now we just do them each on their own. Right? So let's see. Answers go in black. Square root of 16. What times what is 16? It's 4 times 4 is 16. So square root is 4 divided by square root of 9 is 3. So there we are. So real quick, if you need to pause the video, here you go. But I'm going to put up one more thing you might want to pause and take notes if you need to. Some of the more common. So if you notice, look at all the answers up here. They go up one by one. So square root of 4, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you have a square root of maybe something between 4 and 9, like 5 in the last problem, if you have a square root there that's between these, you know it's going to be some weird decimal, and it's not going to be nice and clean and simple. And we want simple. So if you can find one of these numbers under a radical, nice. It makes a nice answer, right? If you can't find one of these, you're going to have to settle for leaving it as square root of some number. Okay? So let's try some practice problems. So this is on the page after your warm-up. This is number 1 of the first page of practice problems. And it says, let's make this simpler. 68. Square root of 68. Sorry. Okay. So what I want to do first is break it up. Okay? So I'm going to break it into the prime factorization. And to do that, we'll go with blue. Yeah. Okay. So I like to do a tree, right? First I check, can this divide by 2? Can we split this into 2 times something? Yes, 2 times, let me check my calculator. 2 times 34. Okay. Can we split 34? Yeah, I think that can split into 2. It ends with an even number. So it's 2 and 17. Okay, now I got to stop and think. Can I split 17 into anything? Well, it doesn't divide by 2. It doesn't divide by 3. It doesn't divide by 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So no, I can't split 17 anymore. That's a prime number already. So here's our prime factorization. We have 2 times 2 times 17. Let's write it up here. So it's 2 times 2 times 17. So when you get to the end of your splitting tree here, your factorization tree, you take whatever's at the ends, and that's your factors. So now we can split it up some more. And I remember the rule from the other board. If I have 2 of the same number, if I have something like this, square root of 2 times 2, and then the other one is square root of 17, well, 2 of the same number, they can leave. These 2 guys, that means that one of them will leave the radical. So we get, over here we get, the square root of 2 times 2 is 2. And we can't change this. If you look at that other board we had, this was between the perfect squares. so we can't fix it. It will stay as a radical. Okay, so the answer is all we did was make the radical smaller, right? This counts as being simple. All we did was we did the prime factoring, and we found out we had two of the same number, which means one of them gets to escape. Well, I'm right in front of the camera. Two of them under the radical, one of them gets to escape. And then this square root 17 over here, it's not a perfect square, so it will have to stay inside the radical. Bummer. Number 2. So the problem we're going to run into with number 2 is dealing with fractions. Okay, so this is number 2 from the same page. Number 2. We have root 8 divided by root 24. Okay, let's split them up. I'm not going to do a factor tree for 8 because it's a little simpler. 8 is just 2 times 2 times 2. That's the prime factoring for 8. Okay, and on the bottom, I'm going to split this up. How many 8s? Well, can this divide by 8? Yes, it turns into 3 times 8. But remember, that's the prime factoring for 8, so we can just copy it down here. 3 times 2 times 2 times 2. Okay? I need a straight edge or something. Okay. Under a radical up here, everything is multiplying. That's good. Everything is multiplying in here, too. If all you have is multiplying, then you can cancel things out by dividing them out. So we have a 2 on top and a 2 on the bottom. A 2 on top, a 2 on the bottom. A 2 on top, a 2 on the bottom. So all that's left, on the bottom we have root 3. And on the top, if the top of a fraction gets emptied like this, by multiplication or dividing, there's always a 1 left over, the invisible 1. Okay, this is the answer, but it's not simple enough for us. We don't want these irrational bottoms, right? This is a square root of 3. That's a crazy decimal on our calculator. We don't want that. We need to figure out how to make this a normal number. The way to do that is through a little trick. Whatever radical you have on the bottom that you don't like, you're going to multiply the top and the bottom by that. Okay? And this is neat because it's a nice little trick. Now we have 2 of the same number multiplying together in a radical. Remember, if we have 2 of the same number under a radical, the answer is just the number outside the radical. So this turns into root 3 times root 3 is just plain 3. Okay? And on top, 1 times anything is that anything. So it's just root 3 on top. And that's okay. We are okay if there's a square root on top of the fraction. We just don't like the square root on the bottom of the fraction. So moving on to the next board and the next set of practice problems, right? Now we're going to make it so it's not just multiplication, so things don't get as neat as before. Okay, so this is number 1 on the second page of practice problems. So if you want to follow along, that's a good idea. All right. What we need to do is break it down as much as we can, like we did on the other board. Break things down to see if anything matches and subtract. So I'm going to split my 8. What is the prime factorization of 8? If we remember it from before, it is 2 times 2 times 2. So I'm going to change that square root of 8 into the prime factorization, which is 2 times root 2 times 2 times 2. Okay. The square root of 2, that's already a prime number. I can't make it any smaller. So I'll bring it down here, minus root 2. Okay. Do we know anything about this first square root? So we cannot put them together. That's one thing I should stop. We cannot put them together. This 2 can't go in here with them because it's not multiplying, it's subtracting. Only when they're multiplying or dividing are they very flexible like that. When it's minus or plus, they can't really mix yet. Okay, but what do we remember if we have 2 of the same number under a radical? That means that these 2 will get outside, but only one of them will. So we have one of these outside. What's left under the radical? This lonely third 2. Okay, bummer. And over here, nothing changed. Minus root 2. All right, this doesn't look much better if you don't look deeper at it. But what do we know? We can pretend. Now we can pretend this is just a variable. So let's pretend that's x. If we have 2x minus x, what do we get? 2 apples minus 1 apple is 1. So 2 of this minus 1 of this means there's just one of them left over, which is just the root 2. So that is the final answer. 3, so this is number 2. We have 3 root 75 plus 2 root 5. Okay. So we know right away that we can't just add them because they are not the same root. And the other problem, we could subtract them. Oh, it's on the same board. In the other problem, we could subtract them because they were both root 2 and root 2. This time, it's not the same. So we want to try to make them the same or get as close as we can. The first thing I want to try is to factor this down, right? So what is the prime factorization of this? Okay, well, I know that 75 is 3 times 25, and I know 25 is 5 times 5, so I'm going to split it into 3 times 5 times 5. Okay, now all those guys are under the root still, and that 3 is still outside. Okay, and the right side, can I make that 5 into prime factorization? Trick question, it's already a prime number. 5 is already prime. So we can't make it any smaller by factoring. Okay, do you notice anything we can get rid of? Anything we can help escape the radical? We have 2 of the same number, which means one of them will go outside. Now, when it comes outside, it's multiplying. So it'll be 5 times 3, that 3 from outside here, and the 5 that escaped. And then we left that 3 behind inside. Sorry, dude. Okay. And over here, still nothing changed. 2 root 5. Okay. Can't help him out. All right. And then let's see. There's one last thing we can clean up. So this is nicer now because we have a very small number. It's a prime number, and it's small under the radical. 5 times 3 is 15. Then we have root 3 because this 3 could not escape. Then we have plus 2 root 5. Okay, so we're done now. This is the answer. This is as simple as we can go. We can't really add them together anymore because this one is a root 3 and this one is a root 5. They don't work together. You could pretend that this is like 15x and this is 2y. We can't add x's and y's neatly. They just stay. Okay, the last problem we're going to look at is number 4 from the packet. So this is the second page of practice problems, number 4. And this one is going to be our FOIL example. So if we have something, this part inside is simplified. Unfortunately, we have to do the square of the whole thing. So when you see a squared outside of parentheses, if there's a plus in there or a minus, you're going to have to split it into the two pieces that are multiplying together. Just like 2 squared is 2 times 2, anything squared is that thing times itself. All right, let's see if we can get all these different colors here. Now we got a FOIL, which is also called double distribution. So we have to give each number multiplying with each number. So 3 times 3, next color. Then this 3 times the root 6. Then this root 6 times this 3. And then this root 6 times this root 6. Okay. So let's do each piece one by one. Starting with red. 3 times 3, 9. Okay. Next color is purple. 3 times root 6. Well, it's just going to be the same. 3 root 6s. Okay. Is it positive or negative? Well, this one's positive and this one's positive, so it's going to be plus between them. Okay. Next color is blue. Let's look at the blue arc. We got root 6 times 3. So that's the same thing as this one. 3 times root 6 times 3. Same thing. So it's positive, we know, and it's 3 root 6. Okay. Then the last color was pink. So on the pink answer, we have root 6 times root 6. Remember, if we have two roots of the same number multiplying together, it just turns into that number. So this is just going to be a positive 6. Root 6 times root 6 is just 6. Nice. Okay, that's a little better than I expected. So now we're going to add things together that can be added together. So we have right here a plain old number, 9. Do we have another plain old number? Yes, 6. So 9 plus 6, that works. We can do that. That is 15. Okay. Next we have something root 6 and we have something root 6. So if they have the same square root ending, we can add them together. Here we have 3 of these. Here we have 3 of these. What's 3 plus 3? It's 6. And we still have, what, 6 of what? 6 square root 6s. And they were both positive, so it's plus. So there might be a lot of questions. Remember our class times. Okay, Miss Roberto and I are online for your class time every Tuesday and Thursday at 11:15 a.m. So 11:15 in the morning, we're here for all your questions. You come watch the video, you say, I'm stuck still. Okay, I'm here to help you. Also, Monday, Tuesday, Wednesday, Thursday, we are here at 1 o'clock. You can come online, give us a chat, or just join us on the video call. Every question we can answer. And second to last thing, on Fridays from 9 a.m. to noon, so 9, 10, 11, and 12, we are online. Again, we'll answer any question.